Hi there, my name is Emmy and I'll be your guide for your final module of Day 5. I'll be talking to you about curve sketching. Please pause this presentation at any time or need more time to think about something. When sketching functions, one way to do this is to choose some x values and find its corresponding y values. Then we can plot these points and connect the dots. Of course, for this to work, you may have to plot many points. But rather than doing this tedious method, it is useful to use the derivative of the function. The derivative of a function will tell you whether the function is increasing, decreasing, or neither at that point. Recall from Day 4 that if the derivative is positive on an interval, then the function is increasing on that interval. Likewise, if the derivative is negative on an interval, then the function is decreasing on that interval. Let's consider sketching the curve y equals to x cubed plus 3x squared minus 9x minus 8. In curve sketching, it is useful to find where the curve will be flat, that is, where the stationary points are. To find this, differentiate the function and let the derivative be 0 and solve for x. We get x equals to 1 or x equals to minus 3. So we find after substituting x equals to 1 and x equals to minus 3 into the original equation, the corresponding y values are 19 and minus 13. Therefore, the stationary points are minus 3, 19, and 1, minus 13. So at these points, the curve is flat. Now let's have a look again at the derivative. Consider 3 different intervals for x. For example, when x is any number that is less than minus 3, then the factors x minus 1 and x plus 3 are both negative. Therefore, the product of these will be positive. That is, the derivative is positive. So in this interval, the function is increasing. We can do the same for the other 2 intervals. It's a good idea to draw a table like you see here when doing this. So when x is between minus 3 and 1, the derivative is negative, and so the function is decreasing. When x is greater than 1, then the derivative is positive, so the function is increasing. You can already start to see the general shape of the curve. Here is a sketch of the curve. Start with plotting the stationary points and form the shape of the curve from what we learned about the function. Now let's have a look at another example. Sketch the curve y equals to minus x cubed plus 9x and find where it crosses the axes. First, find the stationary points. The process is the same as before. Differentiate, let it equal to 0, and solve. We find that x equals to plus minus square root of 3, and the corresponding y values are plus minus 6 times square root of 3. So the stationary points are minus square root of 3, minus 6 square root of 3, and square root of 3, 6 square root of 3. Construct the table as we did before. Recall from the previous model, we know that the stationary point is a minimum turning point if the gradient changes from negative to positive, from left to right through the stationary point. And the stationary point is a maximum turning point if the gradient changes from positive to negative through the stationary point. Can you determine the nature of the stationary point we found are? To find the y-intercept, we substitute x equals to 0 in the original equation. Here we get y equals to 0. So the curve crosses the y-axis at 0, 0. Now for the x-intercept, we substitute y equals to 0 in the original equation and solve for x. When factorized, the equation becomes minus x times x minus 3 times x plus 3 equals to 0. So we get x equals to 0, x equals to minus 3, or x equals to 3. Therefore, the curve crosses the x-axis at 0, 0, 3, 0, and minus 3, 0. Note, you can check your solutions by substituting the coordinates back into the equation. Here is a curve when sketched. Were you able to identify the nature of the stationary points before seeing this sketch? Notice that we have labeled all intercepts and the stationary points. Keep in mind it is good practice to label your axes as we have done here.